What's up, everybody? This is Sparrowwood again from Sleepless Nights with another chapter in How to Train Your Turtle. Today we are going to be working with the big Mac Daddy of our BeeDabase program, and that is the BeeDB handler script. Right? Yes, I got it right. Alright. So, now we're going to get to the real meat and potatoes of this script, which this is what's going to get the information, format it all, which, believe it or not, was one of the hardest parts to all of this, was getting it all to format correctly. Now, I will admit, I've kind of compiled this over probably a week's worth of scripting and blah, 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 just off and on every now and again. So I can't really guarantee that I remember why everything is the way it is, but I will try and walk through it and it should remind me. So first off, we've got the peripheral wrap, which is pretty much the same as all the other ones. It wraps in the front because if you'll remember, the advanced computer is behind the monitors down there. This you would just change based on whatever direction yours is sitting at. I may end up changing it eventually, depending on if I move that, which I'll most likely do. Okay, now this gets into some nitty-gritty stuff. So we've wrapped the monitors as M, so m.getSize will return two coordinates, the X and the Y values. So I believe that would be like what this coordinate down here would be for, because technically upper left should be 0, 0. I mean, as long as it follows standard programming protocols. So your Y value should be all the way down here, so it'd be like where the press control, that should be the Y value, and then the X should be where that 2 value is. I believe that's what that's for. Okay, P table, I don't, I gotta be honest, I forgot completely why there's a P there. I think what I was thinking was parsed table, so like all of the strings and information has been parsed and formatted correctly. But I gotta be honest, I don't know why that's there. So P table is pretty much what we use to store the final table. BeeDB is the table we use for getting the information and editing and all that stuff. P table is what we end up print table, maybe that's what that's for, is this is the table that should be printed. I don't know, we'll say it's print table or parse table, whichever makes more sense to you. K up and down is for keys. These are the numeric values. You can look this up on the let me think, Computercraft wiki under the os.pull event. It should list the different events that it has, one of them being key. If you click on key, it should show you a diagram of what all the numeric values are for each key on the keyboard. So this is for the up arrow, this is for the down arrow, and I just made variables for them so I wouldn't have to remember what these two numbers are for. Table I is going to be shown in a minute. It's for table index equals 1. Starts at 1. Not entirely sure why I started it at 1, but I'm sure it'll make sense. Offset is for scrolling. It's for as you scroll, it shows what table entry to show and how many to offset it because of how far you scrolled down and so forth. Limit is going to be the limit of how many entries can be printed on the screen, whether it be let's see, whether it be whether or not the table, P table, doesn't have any more entries, or whether it be that you've reached the end of the monitor. Last update, these last two were something I threw in last night while I was working on this, but I have to admit I'm not entirely sure that they work correctly. I believe they do. But it's still not entirely the way that I really wanted them to work, but they still function plausibly. Like, they still work, but but it didn't do exactly what I wanted it to do, but it was still an improvement over the way it was before. Okay, save file, pretty self-explanatory again. It opens the BDB in the right formation, serializes a table, and stores it and closes it. Load file's pretty much the same, except that it's loading from the disk, which we covered in the last episode. In the read function, it reads all and closes, yada yada yada. Now, I did do it to where you have a local variable called t, and it unserializes the data from the file and then returns the table. So this load will return a table. That's important because you can't store it into a string. Let's see what else we got. All right, update DB, so update the database. What this is going to do is take the BDB file, and again, you can load this up with arguments. You could have a store table, end table, all this. That you could throw in the variables that you wanted. Personally, I just knew I wasn't going to be using this particular function for anything else, so I went ahead and just hard-coded the variables in. Either way, doesn't really matter. Technically, this is more restrictive because you can't change the variables unless you go in manually and change them all, but again, if you know you're going to be using it for one thing, it doesn't really matter. And I haven't had time to go back through and comment all these as much as they probably should, but that's what these videos are for. So it loads, again, we showed the load function, so it loads the information from the BDB disk file and puts it on there. The p table is then equal to, okay, this function is down here, and I haven't shown you this, but let's see. Let's just show that first, because that's a long one that's going to take more time than that other one. So this is the huge concatenate and set up the final table to be printed file. I shouldn't say huge. It's not that big a deal. It's just a lot of little stuff that goes on a lot. And it's a lot of tiny little intricacies to make everything all set up correctly. It's bleh. Be thankful. If you use this script, then I have done a lot of the work for mathematics and stuff. It's not fun to actually try and... Because the only way I could figure this out was to do it multiple times and just see what looked right and what didn't, and bleh, a lot of time. So... alright, so we declare a blank table at the top, just for editing purposes. It won't last outside this function. Notice that we load in first table. So first table, if you'll notice up here in the update function, we have a concatenate table set up, BDB. So we take this function and put it in here. So essentially down here when you see first table, it's going to be the information from the disk, basically. Scroll please, thank you. Okay, so blank table, and we've got the entry table with all the values. Alright, so we do a 4-key value in pairs from the information table from the disk. We declare a string, and string is equal to the toString of key. So key should be whatever entry we're working on. For example, we'll just say diligent, right? So if we're looking at the diligent index for the file on the disk, then key and string is going to equal diligent then. Now we load 3 new variables, D, P, and Q for drone, princess, and queen, right? So get drone value. Oh, and this says up here loop through each species. So we're going to get the drone value. So if the disk info table at toString drone, right? Now, this was basically so it's if you throw a B in the B analyzer and it makes an entry in the database, the toString key, come to think of it, you could just put str there because we just took that value and put it in string. Not entirely sure why I didn't do that, but whatever. I was programming this at like 3 in the morning, so you can change that if you want to slim this down a little bit. It's up to you. I personally am going to leave it because it's working and I don't want to mess anything up. But anyways, this would be like diligent. So the disk info diligent, but then I've already narrowed it down that there's only going to be 3 entries here. Like, this is the species, this is the class. Well, out of the classes, you've got drone, princess, queen. So these 3 if sequence here is if the species has a drone entry, aka not equal to nil, then D is equal to D colon, and then dot dot first table to string. So it's basically going to add D is equal to D and then the number of drones for that species, right? Otherwise, D is equal to 0, like so. Same with princess, it goes through species, princess is not empty, then add P, species, princess value, otherwise at 0. Same with the queen. The casing and everything is important here because this is exactly how the Bee Analyzer will label these. So if you did it with a cap or something, it will always return nil because there won't be an entry for that. So that's important to note. But all those 3 are the same. Alright. Let's see. Set proper line format. This, I took this line, you may recognize this from the analyze. I put this in here originally and then took it from here and put it in analyze and just, I kind of just left that in there. It doesn't screw anything up or anything, it just, in theory, it shouldn't ever equal this because the analyze script in the turtle should be fixing this already, as we talked about in the last chapter. So it's here, you can leave it if you want. Don't quote me on it, but I think you can take this out safely, this if sequence from here to here. I think you can take that out safely, but yeah. Again, I probably won't just because it's not broken right now and it's working, so I might experiment with later with the final version or whatever. Now, this gets into some funky calculation that I just had to do on my own. Basically, local count is a new variable, and then it says if the length of the string, which as you remember is the length of the species. So in our example so far, we're using diligent, right? So if the length of the string is less than 20, which my math is rusty, but I'm pretty sure diligent is less than 20 characters, then count is equal to 20 minus the length of the string, right? And this is all going to make sense in a minute, but this is basically setting up, if you recall, the species list on the left was different different lengths, and then the D, P, and Q were all at equal length, like everything was all equally spaced. This is how you do that. So we set the count to equal to 20 minus the length of the string if it's less. Otherwise, it's going to be greater than 20, so it doesn't matter. And then, well, I don't think it matters. Oh, this is all part... Okay, sorry. This is kind of... Why is this all disorganized? I don't know why this is the way it is. This should be like so. All of this should be moved over. In essence, this is all part of, like, here's the end to that if. That's because I did it in Notepad++ and it got all screwed up. So if string is less, or the length of the string is less than 20, it sets count to 20 minus the length of the string. Then it goes into a for loop where we start at 1 and then go to count, and string equals string plus spaces. So basically, in a nutshell, what this is going to do is always make sure that the species line ends with out at the 20th character, basically. So even if it's, you know, viz, which is obviously 3 letters, that's not going to be 20 spaces, but to keep everything even, it takes 3 minus 20, and then it loops until 20, and it keeps adding, 17 spaces to the end, so it still comes out to the 20th character. In hindsight, the other way you could do this is set the cursor point of the monitor out. Do I have another? I do. So you could do something like, I don't remember the actual thing. I think it's like this, or is it lowercase? It may be lowercase. Set cursor position, and then make it like 20, and then the Y value of where you want to go. You could also do something like that. In hindsight, again, 3 o'clock in the morning programming, wasn't thinking about that, but again, you can copy this directly in and it works. That's the important part. You wouldn't have to modify it all that much or at all for this to work. It's just, again, refer back to what I said in last chapter about I don't know that this is the most efficient or simplistic route to get to the function, but for those of you that are not real familiar with programming and you don't want to worry about it, you can just directly copy and paste this into the thing and it'll work, so you don't have to worry about that. But yeah, hindsight and the final version, because again, I'm still tweaking this a little by little, still work in progress, because I still want it to just update automatically without you interacting with the computer. So as I work on it more, I may, now that I'm looking at it and walking everyone through it, I notice things like that you could just do a set cursor point and stuff. So I may, in fact, go back and edit some of that out and clean it up. But anyways, for now. So then it moves on and says string equals string dot dash, so, or space dash space, so that adds, you're at your 20th character, so it spaces out and adds that. Oh, that's the other thing, is this isn't just writing it right now. So that's the other reason that I didn't do a set cursor point. This is storing it in the string variable. So when we get to the end of this, I'm pretty sure that we end up just writing string to the thing. So now that I think about it, that's why I didn't do a set cursor point, because we're not writing here. So this is all being stored in one long line. So we've got string equals string plus the dash, then if d, which if you'll recall stores the drone number, so if length of d is less than 8, which including the d and the colon means a 6-digit number. So if it's less than 6 digits, then count equals 8 minus number or length of d. And then for I equals 1, so same idea here, we're adding spaces to the end of the drone count to line it up. And again, these numbers, the 8, the 7, all that was just trial and error and what I thought fit well on the monitors. You could go in and tweak these numbers, set this to 12 if you want that many rows for the princesses or whatever, but I just tweaked them as I went. Same idea here. Checks the number of, or length of princess digits. If it's less than 7, it sets it to 7 minus the digits, and then loops through adding spaces. And because we're adding P here, it's already the information. So we've set the amount of spaces for D, and then you just go ahead and add the P digits, and then, or princess, values, and then you add spaces to pad that at the end. So, we're already adding the information. So Q equals Q, same thing, I had 3 digits for that. So now each string, or each value has all the stuff stored with the padding. So what we do here at the end is concatenate string equals whatever the data is for the string already, the drones plus a space plus the princesses plus the space plus the queens. So that is your whole row. So you'd have diligent, drone, or dash, drone, princess, queen type of thing. So that's all in the string value now. Now, okay, forget what I said about the set cursor point. I wasn't following my line of thought through. This is why I didn't do that, is because I'm storing it all in a table. So you make one row that holds all the information for one species, store that in the table, and then continue. This is also where I will probably end up implementing some kind of alphabetization. If that's not a word, that was a lot of work for a fake word, but I think it's a word. So we're going with it. Alphabetization. You know, after saying that, I don't think that's a word. Anyways, so we take the T we declared up at the top, and we use table index, which if you recall is set to 1 at the moment, and then we store the string value in it. The reason it's set to 1... Why is it set to 1? I think it's because somehow the way I set this up, it starts at 1, like down where it prints anyway. Yeah, it's because of the offset variable thing that it's already at 1, so in order to get the first value of the table, you have to start at 1 and skip the 0 index, because we're going to use offset in a minute. So we store the string in that one, and then increment the table index. And so this keeps looping through until it's got all the information off the disk, and then it resets table index to 1. Because this gets called during the update loop, so you have to reset it so that it goes back from the beginning and sets everything up again. And then it returns T, which is where we stored all of it. So it returns a table with all the info. So we'll go back up to the update function. A lot of scrolling. I'm glad I did this on a advanced computer. Okay, so now that you know what concatenate table setup does, we take the information from the disk, put it in there, it builds the table, returns the formatted table. I think now that I'm thinking about it, that is what that P stands for. It's the print table. So it loads it into there. And then limit. Now this was a funky little function that I didn't know about, but it's a Lua function. And it's called math.min. And what it basically does is you input 2 numeric values and it determines which one is less. It's a pretty handy little function. So mh, if you recall, is the monitor height. So what we do is which one is smaller, the number of entries in the table through the print table. So if there's only 3 B's, and like in this case, monitor height would be big. I don't know how many actual lines this will fit. I think it's like I want to say 4 per monitor, because I think the one down in my storage room with the BeeDabase currently is 12, and there's 3. So 1, 2, 3, 4. 4. So I think this should be 16. Ugh, excuse me, I had to sneeze. So this is basically going to look and say, okay, is 16 smaller, or is, for example, if there's 4 entries in the table, you know, there's only 4 bee species so far. You know, is 16 lines bigger than 4 entries in the table? Yes, it is. Okay, well then 4 is going to be returned to limit because it's looking for the minimum between the 2. So this is handy for scrolling because it says, do I need to scroll, or, you know, or how far to scroll, you know, all that good stuff. And it lets you know, because it lets you basically do math and figure out if you've passed the monitor height or not yet. And then local if update equals the length of the table, number of entries, and then if last update is less than if update, okay, then last update is equal to the current if update, and then needs update equals true. Now I know this is probably didn't sound all that good, but the first time this runs, what is last update set to by default? I forget. There you are. 0. Okay, so last update is set to 0 the first time this program runs. So what's going to happen is after it's loaded up the information on the table, it is going to say, okay, for example, say that there's 2 entries. So 2 is going to be added to if update. So then last update, which is 0, is less than if update. So then we're going to set last update to this, which would now be 2, and then needs update will equal true, right? So this comes in handy because if this function gets run, because it gets run every loop, which, you know, it gets run a lot. So if the other computer that's listening and updating the disk information hasn't changed anything, then the number of entries in the print table that's stored in here will equal however it was the last update because it hasn't changed. So then this will not be true and needs update will not equal true, right? So this is a way that I've set up to figure out if the information on the disk is different from what's currently being printed, kind of thing. So now we're going to go, I'm hoping we have enough time to finish this up. This is a big program. This is a big old program. So let's see, what line are we even on? 147, so it's a pretty big one for this. So now we get into the main program function, right? All right, so set the preprint settings, which eventually is going to have I'm going to tweak some of the numbers and I'm going to have like a little banner up at the top, kind of like this right here that says main program. It's going to say, you know, like Sparrow's BeeDabase or something like that. So that will be included in these preprint settings that only go once type of thing. So first it clears the monitor, then it sets the cursor to 1, 1, which is right there, I believe. So I stand corrected. The top left corner is not 0, 0, it's 1, 1. And then we're calling the update database. So I explained this is why some of the functions are set up the way they are, is because it gets called every loop. Last update is now equal to the print table, right? Or number of entries in print table, my bad. And then for the first run, we're going to go from I equals 1 to limit, which we already explained how the limit is. At this point, it would be the length of the table because it's doubtful that it's got that many in it. And then m dot set cursor. Oh, okay. So then it sets the cursor to 1, which would be all the way over here, and then I. So every time the loop goes down, it moves down a line. So the first loop is here, second one's here, third one's here, so on, and that's what keeps moving the table down. Now this is where it gets a little tricky. m.write, so monitor write, is print table and the index of offset plus I minus 1. Now, some of you are probably going, huh? Why the heck is it I blah 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 blah? Well, this is basically, again, not probably the best way to do it, but it worked. It was, after a bunch of trial and error, this was the algorithm that worked. So I stuck with it, and I haven't messed with it, and it's still working, so I'm using it. There's probably somebody out there that if you watch this are going, well, there's a way easier way to do that. There probably is. This is just what I came up with, and it worked, so I didn't mess with it. But basically, what this is going to do, offset is equal to 1 at the moment, right? So then I is equal to 1 the first time it runs, minus 1, right? So then that makes it 0, and offset is 1. So it's going to go to the first index, which we talked about, is the table is skipping the 0, so that the first index is going to be the first thing up there, and it's the first entry in the table, and we're not missing a value, right? Now, when it goes to 2, 2 minus 1 equals 1, plus offset, which is still equal to 1, so that's 2, right? So now it's going to be the second. So this keeps it on track for now. And it comes into play a lot more in a minute. Then we've got a input loop that monitors for key input, right? So that you can scroll down. Now this was, to be honest, one of the most tricky parts to do, and it was not fun to program, honestly. So we have an infinite loop, which the very first thing is it runs the update, so it checks the database to make sure everything is, up to date. And then it does a local event and key equals pull event. Now this is what I was talking about as far as this is why you have to click on the computer and hit up or down in order to refresh the screen, because if you look into the way the pull event works, is it's going to stall here until it gets an event, which naturally the computer's not getting an event, so you have to make an event by pressing a key. It can be any key, actually. I think. I'm pretty sure it can be. Yeah, because I have a else if command down here. So it's going to wait till it gets a key, or whatever. So now it's going to check event to see if it equals key, which means a key has been pressed. So if event equals key and key equals the k down function, and length of the table is is greater than monitor height. This part is very important. This screwed me up for quite a while before I figured it out. This keeps it from, okay, you pressed the key. Did you press down? Yes, you did. But the length of the table is less than or equal to the monitor height, so now I don't want you to scroll down because everything still fits on the monitor. So this basically makes a check to make sure, do you need to scroll down? Like, has the table exceeded the monitor height? If it has, then we clear the monitor, and then if offset is less than the length of the table minus monitor height minus 1. And I'm trying to remember exactly why I was minusing 1 there, but again, all this works. I don't remember exactly why I did it this way. I think it was because, let's see, monitor height, say this is 16, so minus 1 is 15, and then minus the length of the table would be whatever the length of the table is. So, say the length of the table is 20, right? So there's more to scroll. So 20 minus 15 would be 5, I think. Okay, so that was set up so that offset doesn't get any bigger than the number of entries that exceed the monitor. Because if you just followed my math there, if there's 20 entries and the monitor can fit 16, then you don't want to go over 4. So as long as it's less than 5, which would be 4, then offset equals offset plus 1. Now if this loops back and it's equal to 5, then this won't trigger anymore. And it will reset the table to, or reset offset to the length of the table, blah, 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 blah. So this if sequence here keeps offset from going past the amount of entries that exceed the monitor height. That's what that's for. Okay. And then else, if event equals key and key is equal to up, then we clear the monitor. If offset is greater than 1, then offset equals a decrement, offset minus 1. And then offset, otherwise, we're just going to reset it to 1. This keeps it from going past the monitor height this way. It makes sure that you can't go past this line here. And you'll notice I didn't put an entry there as far as is it greater than the monitor table height or whatever. And that's simply because the offset starts at 1. So the only way for it to get further is for you to press the down key. And if you've pressed the down key, then you can only set it to the length of the table, which means it can only go back up so many times before it reaches 1 again. So, again, not sure it's the most efficient or the most best laid out, easiest to read, whatever you want to call it, but it works. The last one is else if needs update is equal to true, and we noticed where that gets called is in the update database call, and if that's true, then we clear the monitor anyway, and then needs update is set to false until it needs an update again. Now we scroll down. Now we've made sets or changes to offset, And now we do another loop to print everything back out. Since all three of these ifs will clear the monitor, we need to reprint the information, but since we're using offset, it will reprint it based on however you pressed keys and whatnot. So that's the end of that loop, and that will just keep looping until you terminate the program or it causes a problem. And then the main program is just you run this thing, it runs once and then gets caught in the input loop, and it'll just keep running until you don't want it to run anymore and you turn it off. So yeah, 191 lines of awesomeness. So yeah, again, there's some issues with it as far as you do have to click on whatever monitor is printing to the, or computer is printing to the monitors, and you have to hit the up or down key, or just any key or whatever to get it to refresh the information to restore it. The only other problem with it is that because it's using the in pairs loop to store the data, it ends up all getting disorganized. Like when you update it, the information may have changed. Like you might have Diligent, Rocky, and Imperial, and then you add Meadows. Well, now it's Meadows, Rocky, Imperial, Diligent. You know, like it screws up the order every time it updates because of the way the in pairs loop works, that it just grabs them in random order. So I'm still working on ideas for how to narrow that down to where it will just always add to the bottom, that type of thing. So I'm pretty sure it will involve creating a sorting algorithm to compare the last entry with the first entry and so on, and then we'll run that before we store the information in the table that gets returned to the print table. But yeah, I haven't worked all that out yet. Excuse me. So, but yeah, this will be up on Pastebin on this episode, as well as the other two that I posted last week. So, I mean, yesterday. So you should just be able to look down in the description and get the 3 links and paste the analyze into the turtle that's set up next to a B analyzer like I have, and then set a computer with a monitor with the get database script next to a disk drive with a disk in it, and then set a computer next to the disk drive that has a monitor next to it, and run the BeeDB handler script on that one. The only thing is, if you change the order of where the monitor is positioned to the handler computer, you will have to go edit that up at the very top, because this is set up for it to be in front of the computer. But as you do have to click on the computer and tap the up or down keys or whatever to get it to refresh, you may want it more like this one is set up, which is next to the side type of thing. That's perfectly understandable. I may do that myself, now that I understand how this is probably going to end up working. So yeah, you would just want to change that first string there to wherever you have, like for this it would be wrap right, and then then the same function would work there. So yeah, but I hope this helps you. I hope this helps organize your bees if you're bee people and computer people like me. So yeah. I'm not done with this project completely. I probably won't post any videos of it again until I've finalized everything to where, you know, it's got the sorting algorithm and stuff in it and all that good stuff. So the next time you see it, it'll probably be after the base is further along and it's like where the bees are going to stay, not currently in the storage room where they are right now. So yeah, I hope this was helpful. I hope you all enjoyed and you learned something. And if you did, feel free to leave a like, comment, message me about any questions or anything you have, anything at all, anything that comes to mind. So yeah, I'll see you all next time. Peace.